Assalamualaikum everyone. Here I'm presenting my lab assignment project of Big Data Analytics course. First, I would like to describe the code. Here you can see all the necessary libraries that I have used in this project. FAISS-CPU for using all the algorithms, SentenceTransformers for creating vector embeddings, and Pandas, Matplotlib, and Seaborn for generating charts and graphs, Gradio and PyNG for the web dashboard. First, I have imported the file message product.csv that has been provided in our course, and I have actually did some pre-processing and cleaned all the unnecessary information. And later, using the SentenceTransformers, all mini-LM L6v2, I have used created the embeddings and the dimension. And later, configuring all the benchmark parameters, I have used some helper function or created some helper function for calculating the memory usage or recall or the search time. And lastly, I've called all the algorithms Flat L2 and IVF Flat, HNSW, and IVF PQ, and then summarized their or analyzed the performance of those algorithms. Now let's get back to our interface. Here you can see the interface. It has 4 components: live search, algorithm guide, performance analysis, and dataset information. This step actually contains the dataset information that I have already mentioned earlier, and algorithm guide actually give a brief description of all the algorithms, Flat L2, HNSW, and so on. And basically, Flat L2 is brute force algorithm, so it will give highest accuracy. HNSW is graph-based approximate search. It actually does some balance between accuracy and speed or memory. And IVF Flat, which used cluster-based partitioning, and IVF PQ, which is compressed vector storage. And now get back to our live search portion. Here you can see the core configuration panel. You can write some query, you can select any algorithms, and you can see your top k results and select the value of k. So I'm selecting 7, and let's say the women footwear under 5,000 and searching. Here you can see the retrieved results. Now let's get back to the performance analysis tab. Here you can see the overall performance here according to some metrics: memory usage, query latency, search accuracy, and index build times. And this one is speed versus accuracy trade-off. From this you can see that HNSW is the best suitable algorithms in this context because it takes the lowest latency and as well as almost the highest accuracy. And in terms of query throughput, definitely HNSW outperforms everyone. And in terms of memory, HNSW takes the highest amount of memory, and IVF, on the other hand, takes the lowest amount. And in the search accuracy, all the 3 algorithms performs almost identical, but IVF PQ actually performs very poor because it actually compresses the data. And during the build time, obviously IVF PQ will take much more time as it does some compression. And after that, HNSW, IVF Flat, and Flat L2 takes the least amount of time. So considering all the scenarios, definitely HNSW actually performs better. And here are some key insights: that the accuracy definitely Flat L2, fastest search is HNSW, memory efficient is IVF PQ. So the recommendation of the algorithms definitely will be for production purpose, HNSW will be the best fit, and for budget constraint, IVF Flat will be good because it will take a little less amount of memory. And if we are using some constraint device like mobile or edge device, we can pick definitely IVF PQ for minimal memory usage, and for the research purpose, we can use Flat L2 for perfect accuracy. Thank you all. That is my project. Assalamualaikum everyone.